Hello students and viewers, welcome back again to Science Capsule, a perfect self-learning tool for school children. In today's episode, we will be starting a new chapter, that is acids, bases and salts. Before going to learn about this chapter, you must have studied in the lower classes about acids and bases. There are a number of fruits which are bitter in taste and there are fruits which are sour in taste, and you must have studied in the lower class that the fruits or the food items which are sour in taste are because of acids and bitter taste is because of bases. And as far as class 10 is concerned, we are just upgrading the learning process, so we cannot taste all the acids and bases. About the acids, what we have studied in the lower classes, they are organic acids or weak acids which can be tested by just tasting. But as far as class 10 is concerned, as far as organic acids and some powerful acids are there, so we cannot test for the presence of acids and bases just by tasting because they are hazardous. So in order to test for acids and bases, there are indicators, we call it as acid base indicators, and there are some other indicators. By using those indicators, we test for the presence of acids and bases. And one of the natural indicator which we are familiar and you must have studied in the lower classes, that is litmus. Litmus is available in two colors, one is blue litmus and another one is red litmus. If it is an acid, then blue litmus changes into red color. So if the solution turns blue litmus into red litmus, then it is an acid. If red litmus changes into blue, then it is a base. So this you must have studied and you should know about it, right? So this is acid. There are some other indicators, for example, natural indicators. China rose extract you must have studied in the lower classes, right? China rose, or we call it as hibiscus. So this is one of the indicators. So all these are the natural indicators. By using this, we can test for the presence of acids and bases. Now moving further, let us understand one more type of indicator, that is olfactory indicator. Olfactory indicator. So when we talk about olfactory indicator, here we will not identify the presence of acids and bases by color change. In acid and basic media, the smell of the substance changes. For example, onion is one of the example, clove is one of the example, vanilla is one of the example. So all these are the examples of olfactory indicators. So basically olfactory indicators are those indicators which change smell on a different media. In acidic media the smell will be different, and in basic medium the smell will be different. So on the basis of this, we can identify for the presence of acids and bases. So this is about olfactory indicator. So when we talk about acids and bases, there are laboratory acids and bases that you should know. So some of the laboratory acids about that we will see. One is the hydrochloric acid. Hydrochloric acid, the formula of hydrochloric acid is HCl. Then sulfuric acid, you must have studied about sulfuric acid. The formula of sulfuric acid is H2SO4. Then nitric acid is also, you should know, nitric acid. The formula of nitric acid is HNO3. So these are the laboratory acids. You should know the formula also, you should by heart, so that we will understand when we go the later section. You will find it very easy. So when we talk about bases, there are bases, right? So when we talk about bases, so there are some bases available in the laboratory, that is sodium hydroxide, one of the important base, sodium hydroxide. Formula of sodium hydroxide is NaOH. Then another one base is calcium hydroxide, also known as lime water. Calcium hydroxide, the formula of calcium hydroxide is CaOH twice. So these are some of the acids and bases. You should know the formula so that you will learn or the remaining portion very easily. Now, so these are the acids, and this can be tested by with the help of litmus paper, and olfactory indicators are there, but with the help of those things we can easily test for the presence of acids and bases. Now, as far as class 10 is concerned, what else we need to learn? So there are some chemical properties that needs to be learned. So we learn the chemical properties of acids and bases. So what happens when acids and bases react with the metal? So here we write metal. Basically, when acids react with the metal, then metal salt, corresponding metal salt and hydrogen gas will be evolved. So we first write the general equation. So here metal plus acid gives corresponding metal salt plus hydrogen gas will be evolved. So in order to expand this, let us take some of the examples. Here we take sodium as an example of metal, and acid we take a hydrochloric acid. Upon reaction, we will get corresponding metal salt, that is sodium salt will be formed, that will be NaCl plus hydrogen gas will be evolved. Let us take some other example. Here magnesium. In place of hydrochloric acid, we will take some other acid, H2SO4. So upon reaction, we will get corresponding metal salt. This will be here magnesium sulfate plus hydrogen gas will be evolved. So what you should remember is, whenever metal reacts with acid, common thing we have to find out. Here you see hydrogen gas is evolved. This is the thing you should know. In all the cases, whenever metal reacts with the acids, then metal salt, corresponding metal salt. If sodium is reacted, then sodium salt will be formed. Magnesium is reacted, then magnesium salt. Or some other metals are reacted, then that metal's corresponding metal salt will be formed. But the one thing remain common, that is hydrogen gas will be evolved. Now, the gas so evolved in these reactions are hydrogen. How can we prove this? So we can take this as an example. You see here, this is the test tube, and here suppose the second reaction we are taking here magnesium. When we put magnesium here, we are adding sulfuric acid, H2SO4 is added, then here gas is evolved. This gas this gas is hydrogen. How can we prove for the evolution of this hydrogen gas? In order to prove this, what we need to do is we need to bring the burning matchstick near the mouth of the test tube where the chemical reaction is taking place. When we bring the burning matchstick, then at that point what happened? The burning matchstick burns with a pop sound. This pop sound is a characteristic property of hydrogen gas. If other gases are evolved in this reaction, then we would not see any pop sound. So the pop sound is produced only with the hydrogen gas. So this confirms that in the chemical reaction, hydrogen gas is evolved. So this is the first chemical property, that is metals, reaction of metals with the acid. Now what happens when metals react with the bases? So when metals react with base, for example, here we write sodium hydroxide plus here we write zinc is a metal. So this is the base and this is the metal. Here what we get is sodium zincate will be formed, metal salt, and hydrogen gas will be produced. Again, whether acid reacts with metal or bases react with metal, in all the cases the gas evolved is hydrogen. This you should know. So this is the first chemical property. Let us understand the second chemical properties of acids and bases. What happens when metals react with metal carbonate and metal hydrogen carbonate? Metal hydrogen carbonate. So let us write the general equation. So whenever metal carbonate or metal hydrogen carbonate react with acid, then we get metal salt, corresponding metal salt plus carbon dioxide plus water. So these are the substances produced when metal carbonate and metal hydrogen carbonate reacted. Let us take an example of metal carbonate. We know that sodium carbonate Na2CO3 is the metal carbonate. When reacts with any acid, here we take example of hydrochloric acid, then we will get sodium chloride, that is the corresponding metal salt, plus carbon dioxide plus water will be formed, right? Now metal hydrogen carbonate, we take Na2CO3 plus, here metal hydrogen carbonate, we are talking about metal hydrogen carbonate, right? So metal hydrogen carbonate, this is not the formula, so here we write metal hydrogen carbonate, here NaHCO3 when reacts with the hydrogen chloride, that is hydrochloric acid, again we get NaCl plus CO2 plus H2O. This reaction needs to be balanced, so we write here, okay. So this is how the chemical reaction goes. Now in this reaction you see, in both the reaction, whether metal carbonate or metal hydrogen carbonate, here acid is the common thing, and you see here carbon dioxide gas is evolved. How can we prove for the evolution of hydrogen carbon dioxide gas in this case? In the earlier case, we have seen hydrogen gas evolved, and by using burning matchstick we confirmed the existence of hydrochloric hydrogen gas. Whereas in case of carbon dioxide, how can we prove? Again we can have a test. Suppose this is the test tube, and here sodium carbonate, suppose Na2CO3 is there, and here we are adding hydrochloric acid. Upon adding, we get a gas is evolved. This gas is carbon dioxide. This we have to prove. Now when we pass the carbon dioxide gas so formed here in the freshly prepared lime water, then what happens? We see here, suppose lime water CaOH2, this is calcium hydroxide. When the carbon dioxide so produced in the reaction course is passed through a freshly prepared lime water, then here we get calcium carbonate plus water. Here white color precipitate is obtained. Now you should know calcium hydroxide is a colorless solution, but when you pass carbon dioxide into the solution through a solution of calcium hydroxide, then immediately the solution becomes, or solution turns milky, that is white. So this shows that the gas so formed in this reaction course is carbon dioxide. No other gas produces or turns white precipitate. This is because when carbon dioxide passes through this, you can see the chemical reactions as well. Here white precipitate is the color of calcium carbonate. Dear students, you should know the color of calcium carbonate is white. So due to the formation of calcium carbonate, here white precipitate is formed. So this, from this equation it is confirmed that the reaction, in this reaction the gas so formed is carbon dioxide. So dear students, I believe you understood the two important chemical properties of acids and bases. Still, if you have any doubt, then you can mention it under comment section. If not, subscribe this channel and press bell icon so that you will be notified whenever I upload a new video. So with this, I would like to conclude today's session. See you all on another day with a new topic. Till then, take good care of yourself. Bye.